from your side. Okay. Now, in the previous session, we want to talk about the algorithms for a binary tree. And we said that the first computation was semigroup. In semigroup, we had two phases. Was semigroup computations upward, and the second phase was broadcasting downward from root to leaves. The first phase was from leaves to root. The second phase was from root to leaves. Now we want to talk about parallel prefix computation on binary tree. Again, this is quite simple and can be done optimally in 2 log p with base 2 with lower bound steps. Why this number? Recall that the diameter of a binary we talked about it. The diameter of a binary tree is 2 log p with base 2 or 2 with log p with base 2 minus 1. You know, it depends on the place of leaves. Again, the algorithm consists of an upward propagation phase followed by downward data movement, similar to semigroup. As shown in figure, the upward propagation is identical to upward movement of data in semigroup. So the first phase, I mean upward, is identical to the upward phase of semigroup. It is similar. It is the same as upward in semigroup. But at the end of this phase, each node will have the semigroup computation result for its subtree. It was the upward. How about the downward phase? The downward phase is like this. We will see it on figure in the next slide. But now, the explanations. Each processor remembers, it's very important for us. Each processor remembers the value it received from its left child. It remembers the value it received from its left child. On receiving a value from the parent, a node passes the value received from above, from the parent, to its left child, and the combination of this value and the one that came from the left child to the right child. So each node saves the value which is received from left child. Saves it in a place. And then one value is received from parent from up. The value received from up is transferred to left child. So it saves the value received from left child, and then it receives something from up. The value received from up is moved to left child, and the combination of the value from up and the value from left is moved to right child. So it has a specific method. The root is viewed as receiving the identity element from above, and thus initiates the downward phase by sending the identity element to the left and the value received from its left child to the right. At the end of the downward phase, the leaf processors compute their respective results. Okay, what does it mean? So we have two phases, upward and then downward. As I said, the upward is like the upward phase in semigroup computation. Okay, so each node, as you know, each node has the initial value. So the nodes have the initial values, x0, x1, x2, x3, x4, the initial values. At each step, the nodes or the leaf nodes combine to each other, and then the result is sent to the parent. So at the first step, x0 and x1 are performed based on, for example, this operation. We do not what is this operation? A general operation. I don't know. It is multiplication. It is summation. I don't know. It is subtract. It is division. I don't know. It is a general symbol. A general symbol. So x1, x0, symbol x1. At the same time, x3, symbol x4 here. At the next time, x2 from this leaf and x3 character x4 or x3 symbol x4 from this node, and here x2 symbol x3 symbol x4, and at last x0 x1 from this one, x2 x3 x4 from this one, x0 x1 x2 x3 and x4. At the end of upward phase, the root knows the final value, final result. How about the downward phase? Is the downward propagation. Okay. We said that in downward, for each node, something is received from up, something is received from left, then the combination is delivered to the right. Okay? So we said that the root receives I identity. Talked about identity earlier. Identity element. The root receives identity element from up. And move it to left. And what was received from left? Here. X0 symbol X1 was received from left. I said that the value received from left is remembered, is saved in some place. The value which is received from up then is moved to left, and the combination of the previous left value and which is from up is moved to right. So what was received from x0 symbol x1? What is received from up? Identity I. So I is moved to left, and the combination of I and the previous left, which was x0 x1, is transferred to right. The combination of I and x0 x1 is x0 x1. Okay? How about this place? What is received at the left child of this place? x0. x0. So what is received from up? I. The I is moved from up to left. The previous left, which was x0, and the combination of previous left and I is moved to right. x0 I x0. How about the leaves? The leaves are values x0 x1 x2 x3 and so on. At the beginning, I mean. About this node, we said that in each node, the thing from up is moved to left, and the combination of left and up is moved to right. So the combination of I and the current node is x0. So at this point, I mean the roots, the leaves, we said that at the end of the downward phase, the leaf processors compute their respective results. So the leaves compute at the end. So now just go forward. What is delivered to this edge? The thing received from left. What is received from left? X0. It is delivered to X to right. From left to right. X0. So we put the leaves aside. How about this place? Or it's better to continue from this place or the root. What is received from the left subtree? X0 symbol X1. X0 symbol X1. No, not gate. It is a tree. Okay, so let me repeat it. I think it's better to repeat and then we'll go to the... Each processor remembers the value it received from its left child on receiving a value from the parent, and now it passes the value received from above to its left child, and the combination of this value and the one that came from the left child to the right child. The root is viewed as receiving the identity element I from above, and this initiates the downward phase by sending the identity element to the left and the value received from its left to right child. So it starts from here, as I said, and send it to this one, and again the identity to left one, and then in this place what is received from left is moved to right, and the combination of left and up is moved to the right. From left up to right, from up to left, and left X0, and up to right. Okay? So here in this one, what was in this one in the previous? X0 symbol X1. In the upward, the values have been computed in upward phase. We are now in downward. So what is here? X0 symbol X1. So X0 symbol X1 from left, I from up, I is moved to left, and X0 symbol X1 combined with I to right. What is transferred to right? X0, X1. Okay? How about the other places. In this place, what is it's better to put vowels. What is the thing in this place? In upward. So now it is received x0 symbol x1. How about x2? X2 is from left. So what is received from up is moved to left, and the combination of left and up is moved to right. What is the combination of up? Is x1 and left is x2. It is moved to right. It is moved right to right. Okay. How about this place? What is moved is received from up x0, x1, x2. So what is received from left? X3. What is received from the parent? X0, X1, X2. The combination of X0, X1, X2, and X3 is moved to right. X, X1, X2, X3. Okay? So now, all of the inner nodes, of the non-leaf nodes, have received the final, its own final result. How about the leaves at the end? At the end, the leaves combine the receiving from up to its own value. Identity with x0, x0, x0 with x1, x0, x1, x0, x1 with x2, x0, x1, x2, x0, x1, x2, x3, x0, x1, x2, x3, x4 with x0, x1, x2, x3, x0, x1, x2, x3, x4. These are the final results, or it's better to say the prefixes. You can see the prefixes from x0 to the final result. The prefixes which are connected, which are related to each leaf. So at the end, each leaf, as we said here, at the end of the downward stream, the leaf processors compute their respective results. How? By combining their own value with receiving value. It is receiving, it is on. It is receiving, it is on. It is receiving, it is on. X4 how combined? X4 is combined with this, with receiving. Receiving, on. Okay, was it clear? What is received from up? What is received from up is transfer to left, and the previous left, not the current left. The previous left, I mean the left which was in upward. The previous left with up is transferred to right. Up to left, the combination of previous left and up to right. It is the formula. And at the end, all of the leaves compute their own results. Okay, was it clear? Or you need to repeat that I repeated? You need repetition? Or was it clear? We start from the root. What is received from the parent of root? As you know, root has not any parent. So we say that it receives identity element. Okay, so we start from the root, from this point. As you know, the previous phase has been done. It is finished now. The previous phase is finished now. I mean upward phase. Upward phase was exactly like semigroup. Now we are in downward phase. In downward phase, we start from from root. I is received by root. It is transferred to left, but the combination of previous left. What was previous left? This was previous left. X0 symbol X1. So the previous left was X0 X1. Is it clear now? You can write X0 X1, or it's better to say 0 1. I mean the one operand is one X0, one operand is X1. So for simplicity, I say 0 1. So it receives the previous left 0 1 from left, and the combination of left and up I is transferred to right 0 1. Okay, how about this place? How about this place? It receives again I from up, because as I said, from up is transferred to left. So it receives I from up. It transferred I from up to left, and the previous left. What was the previous left? X0. What was previous left? I mean upward. The previous left, X0, and the previous left x0 and I to right x0. Okay, it's finished. The left subtree is finished. The left subtree. How about the right subtree? How about the right subtree? What is received from up for this one? What is received now from up? x0, x1. Okay, up to left, up to left, and the previous left. And the previous left. What was the previous left? x2. The previous left, x2. And what is received now from up? 0, 1, 0, 1, and 2 to right. 0, 1, 2. 0, 1, 2 to right. Okay? How about this place? So, in this place, what is received now from up? 0, 1, 2. And what was received from left? x3. So, x3 from left, 0, 1 from up, and the combination to right, 0, 1, 2, 3. Okay? 0, 1, 2, 3. So now we have done all of the inner nodes. How about the leaves at the end? Each of the leaves, each leaf, what is received from up is combined to its own data, to its own value, and its prefix is done. I x0, 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 x1, x2, x2, x0, x1, x0, x1, x2. How about this? How about this? x0, x1, x2, x3. This one. And this edge. x0, x1, x2, x3, x4. This one. So what is the formula is like this. The thing which is received from up is transferred to left, and the previous left, I mean in upward phase, the previous left, and what is received now from up, this combination, the previous left, and what is received from up is transferred to right. And we have at the end, the leaves compute the final values related to each other. Okay? So we had parallel prefix computation on a binary tree of processors. Like it was very important for us. We have another node function in parallel prefix. We had two binary operations, one during upward propagation phase and another during downward propagation phase. You see a symbol here. What is in up? What is done in upward? In upward, one from left one from left is combined with one from right in upward. But at the same time, one from left moved for, or it's better to say, it is moved for downward. Okay, in upward, one from left, one from right is computed and then saved somewhere and go up. How about in downward? In downward, as I said, the thing which is received from up to this node is moved to left. From up to left. And the previous left, it is the previous left. The previous left and what is received from left are combined to each other and then go to right. It is a symbol. It is a symbol for these operations: upward propagation and downward propagation. Okay? Upward, downward. As I said, it's exactly the same as the formula: up, from up to left, the previous left, and up to right. From up to left, the previous left, and up to right. It is exactly same as the value, same as the formula I said. Yes, it's the formula. Okay. Okay, now we want to talk about packet routing in a binary tree. The algorithm for routing a packet of information from processor I to processor J. We want to route from processor I to processor J on a binary tree of processors. Depends on the processor numbering scheme which is used. So it depends on the numbering of processors. We have different numbering schemes. The processor numbering scheme shown in figure is not the best one for this purpose, but it will be used here to develop a routing algorithm. The indexing scheme of figure 2.3 is known as preorder. So we have, as you know, as we had in different previous courses, one indexing is preorder and has the following recursive definition. It is the definition of preorder. Nodes in a subtree are numbered by first numbering the root node, then its left subtree, and finally the right subtree. So the index of each node is less than the indices of all of its descendants. We assume that each node, in addition to being aware of its index, self, its own index, we name it self, in the tree, which is the smallest. So we assume that each node, in addition to being aware of its own index, we name it self, which is the smallest in its subtree, knows the largest index in its left, we name it max L, and right, max are subtrees. Okay. So we have preorder indexing here. All of the slides are important. Let me finish the course now, then we will talk about the miscellaneous things. Okay, what is this indexing? It is pre-order. As we talked about pre-order, we start from root, then we go to next subtree, after, and then we go to left subtree, after left subtree, we go to right subtree. So we start from this point. We name it 0, P0. Then we go to left subtree, or when we go to the root of left subtree. What is the root of left subtree? This one. We name it P1. Then we go again to left. We name it P2. After left subtree, we can go to right subtree, P3. All of these nodes are labeled. Then we are allowed to go right. After 3 is 4. We go left, 5. Then we go right, 6. We go left, 7. Then 8. We name it pre-order indexing. Pre-order indexing. It was the first step, indexing. How about routing? It is like this pseudocode. A packet on its way from I to node dest and currently residing in node self is routed according to the following algorithm. So we want to send from I to dest, and the current node is self. Now we are in the self. If dest equals to self, what does it mean? It means that we are at a destination. Then remove the packet, done. Else, if dest is less than self, or dest is more than max R, less than self, or more than max R. What was max R? Max R was the largest node index in the right subtree. The largest node index in the right subtree. If this is less than, if the this is less than this, smaller than this, or this is greater than max R, then root upward. Why? Because we must go to the root to find the destination. Else, if this is less than max L, then root leftward, else root rightward. It is based on pre-order. It is based on pre-order. Okay, if you want to know it exactly, you must read it again and again, and then repeat this routing, and then on this one, implement it on this one. Here, this indexing is pre-order. How about this one? This node indexing is a representation of the path from the tree root. It is another indexing. How? We find first, we find the height of the height of the tree. The height of tree is 3. So at the beginning, we write 3x. When we go left, we name LXX. When we go right, we name it RXX. Then we go again left, We name it LLX. Then we go right. LLRX. Then when we go left from this point, RLX. Then when we go right, RRX. From this point to left, RRL. From this point to right, RRR. You name it. Representation from root to the leaves. These are two indexing schemes. Preorder, as I said, it has a recursive formula. First we go to root, then left subtree. After finishing all of the nodes in left subtree, we are allowed to go to right subtree. P0, left subtree, P1, from this point to left, P2. All of the lefts are done. So we can go to right, P3. All of the lefts of P0 are done. Then we can go to right, P4. What is the left of P4? P5 here. We name it P5. Left is done. Then we can go right. P6. After this, we must go left. P7. Left is done. We can go right. P8. It is preorder. Preorder indexing. Okay. So based on preorder, we write this pseudocode, which is based on preorder indexing. Why these codes are written here? You must examine different examples. I mean to receive all of the things about this one. You must write, you must draw a different balance tree for yourself and implement it and run the pseudocode on each one. Then you can receive the meaning of this pseudocode. Why if dest less than self? Self is the current node. Dest is the destination. Why? If dest is less than self, then we go upward. Tell me why? When dest is less than self, self is the current node. The current node. Dest is the destination. If dest is less than self, it is the x of destination, I mean. If it is less than self, we must root upward. Can you tell me why? For example, we said that dest less than self. For example, dest is 0. Self is, for example, P1. Then we must go upward. Am I right? Dest and current. For example, we want to send from P2 to P0, and now we are in P1. Self is P1 or 1. Destination is 0. Dest is less than 1. Okay? 0 less than, smaller than 1. So we must go up. Okay? 1. Condition here. One condition here. Another condition. Dest is greater than max R. Dest is greater than max R. For example, we want to send from this point, self is 1, dest is 4. What is max R of P1? Max R of P1. Can you tell me what is max R? It means the index of the maximum index of right subtree. We name it max R. The maximum index in the right subtree. What is the max R of P1? P3. Max R of P1 subtree related to this point is P3. So 3. The max R is 3. The destination is 4. Destination is 4. Max R is 3. 4 is greater than 3. Yes. Then root upward. In this case, you just must go upward in order to find the destination. So in two conditions, in the first condition, dest is less than self, or dest is greater than max R, we must go upward. Both are correct. How about this one? Dest is equal or less than max L. For example, dest max L. What is, for example, we are here in P4. We are in P4, yeah, I mean the self is P4. Dest is less than max L. Dest is less than max L. For example, our dest is P1. What is the max L of P4? What is the max L of P4? Max L, not max R. We are, for example, in P4, or it's better to talk about P1. Dest and max L. For example, we want to send from P1 P4 to P1, P4 to P1, P4 self, P1 dest, and what is max L? P5. Yes, P5. So self is 4, max L is 5, dest is 1. Dest is 1, max L is so correct. So it's correct. This is correct. Dest is 1, max is 5. Then we root leftward. What does it mean? It means that we must go left. Okay? And you can find other examples about this. About broadcasting, broadcasting is very simple. Processor I sends the desired data up the root processor, which then broadcasts the data downward to all processors. First we send the value to the root, and then the root broadcasts it down to all processors. It's very simple. Okay? Okay, for sorting, we have We have a pseudocode. Are you tired? Okay, so it's enough up to slide number 40 for your exam. Okay, your exam is up to slide number 46, broadcasting. As I said, you must think about it, about this pseudocode. Why these conditions, these ifs, this my less than self, we must find out different situation, different combination of source and destination, different combinations. Then we can find out when we must go upward, when we must go leftward, when we must go rightward. As you know, we have three different movements: one upward, one leftward, one rightward. Rightward and leftward are downward. Upward is only one. Okay, so think about it. Think about it. If you have any question, you can send me. But before that, think about it. As I said in the group, in the WhatsApp group, the date and the time of your exam is determined, and I sent you in the group one uh, important thing in the exam, in your exam, is that please upload to the Done, and at the same time send your answer sheets to my WhatsApp. I mean directly to my WhatsApp, not in the group. At the same time, and WhatsApp. What do you mean by our option or not? Between these two methods, two ways? No, both. I mean the both, because maybe we have some problems in Done. Then you must have send it to my WhatsApp at the same time. I mean send both. Send through the both ways, not only one, both of them. Okay, if you have any problem in Done, you can then send me via WhatsApp, but it's preferred to send via Done. It's preferred. The WhatsApp is the alternative. No, it's not possible to send the questions in the WhatsApp based on the rules. I mean, based on the rules of your university, we are not allowed to do like that. We are not allowed to send the questions. No, the questions must be sent only via the Done. Only. We are not allowed to do so. And about, you can send me via WhatsApp. I can receive from you in WhatsApp, but I'm not allowed based on rules to send in WhatsApp. It's illegal. I think Don will not have any problem in that day. I mean, in the exam days, the officials are trying to remove the problems these days. Okay, I will assign enough time. Don't worry. no problem. I will assign enough time so you can enter the exam and answer it, and then capture it and send to me. All of, as I said, all of the things which have been covered are important for us because the things are continuous in our course. The things are connected to each other. First, we talked about computations. Then we talked about architectures. Then we combine them with each other. So we cannot remove any part. All of the parts are continuous. We have not discrete parts. So we cannot remove them. So all of the topics covered, all of the topics explained up to now are important for us. But what is important for me? The thing which is very important for me is that to write the answers yourself, not to copy from other students. As I experienced previous semester, in the previous semester, some students have copied and paste, exactly copy and paste from other students. So it's not acceptable for me to only, I think in the previous semester, I have more than 10 papers, 10 answer sheets, which are 99% similar to each other, 99%. Even the semicolons, even the columns, even the dots. So it's not acceptable for me to act like this, at least this semester. Okay, so all of the parts are important because I have explained more in this semester. So all of the parts are important for me up to slide number 46. All of this, all slides, except the slides which I told you that these slides are not important. Rather than those, all other slides are important. Okay, so first, as I said, send me at both Dawn and WhatsApp. Next, please do not copy from internet. Do not copy from your classmates. Please write the answers yourself. You have enough time. So write down the answers by yourself. And about the questions, about maybe 4 or 5 questions, which are all descriptive. We do not have multiple choice questions. So you must write down the answers and then capture with your camera and then send it to me. Please, another problem which I had in the previous semester, please take a high resolution picture. Please use a good camera because I want to read it. Sometimes it's not obvious for me to read it. Okay, please send me a high resolution picture. Okay. No, as I said, it's not possible for me to send you in WhatsApp. It's illegal for me based on university rules. it is illegal for a professor to send the questions in the WhatsApp. No, it's not possible for me. No problem. Send your big size pictures in the WhatsApp. No problem. It's about 4 or at maximum size 5 or 6 megabytes. No problem. Okay, any other questions about the topics and about the miscellaneous things, exam? Okay, as I said in the group, 10 points is for your final exam and 10 points for your class activity. Half, 10 for final exam and 10 for class activity. Yes, the questions are very easy. You must have some drinkings and some eatings, I mean good things to eat. You are going to answer the questions because it is like drinking a water. نمونه سوال. For example, I will ask you to draw a binary tree, a balanced binary tree, and then complete the upward and downward nodes and explain each node. For example, I will ask you this node and this node. You will tell me identity is received from up, x0 is received from left, and the combination of up and left is delivered to right, x0. For example, I ask you, what is delivered to right? Why? What is delivered to the right child of this node? Tell me why. And what is delivered to the right child of this node? Why? Tell me why. You tell me. This one is received from up. This one is received from left. The combination of up and left is moved to right. This is an example. For example, I will give you an example of linear array sorting with internally sorted keys. The initial values are written. So I will give you the initial values. For example, with P9 processors, and I will ask you to sort it with odd even transposition, with odd even, and tell me how many steps are needed. Then you go through the algorithm odd even and show me in each step what is happened. in each step. Another question. In this one, again, I will give you an example in this one and ask you for sorting externally. And you must show me each step. And this one, I will give you, for example, the initial values different from this one, different from this one. Then I will ask you to computing prefix sums on the linear array. You act exactly like this, but the numbers are different from this one. And again, in this one, and again in semigroup, we can have different initial values and run the semigroup computation on it. And we might be asked about the maximum node degrees, network diameters, and bisection width in each architecture. I mean in shared memory, binary tree, in linear array, in 2D mesh, in torus, and so on. Okay, I think it's enough about this chapter, and the first one was, I think it was clear. In the previous one, we talked about, for example, uh, different evaluation formulas. It was important for us, and we talked about Moore's law. It was important for us. We talked about a speed of light argument. It was important for us. A speed of light argument. It was important for us. About Amdahl's law. We talked about Amdahl's law. It was important for us, and all of the things we covered. Okay, any other questions? If you do not have any question, we can stop our courses up to now, and then we will see you in the exam. Slide 7. Here, in slide 7, do you mean here? In T1, okay? What is the result? Do you mean the prefix by the result? T0 or T1? Which one? So the T0 is the time which have not done anything. It is T0. What is T1? T1 is the time where S0 is done, where S0 is generated. The first prefix is S0. S0 is done in T1. S1 is done in T2, and so on. S0 is done is T1, S1 is done is T2, and so on. In T1, yes, we have S0. In T2, we have S1, and so on. Any other questions? Based on the source, what do you mean? What do you mean by source? All of the things which I have taught in the class are important, not more than that. Only the slides which I talked about, not the other things in the books. No. Our source is our slides, not the books. The books is for your extra study if you want to find more. But our exam is based on the slides and the explanations. Prime no important is not. What do you mean? I don't know what do you mean by prime no important is not. In slide 24, let me go to 24. Okay. For T1 prefix, result is P0 plus. What do you mean by P1 prefix? This one, do you mean? It is 5 plus 2. And in the first step, 5 is obtained from 5 plus 0. Yes, 5 0. Yes, the next one is 5 plus 2, 7. Yes, it is T0, it is T1. By contract, I mean. Okay. It is the initial value or T0. It is the first step or S1 or T1. At the first step, the first is the same. The second one is the summation of first and second. Okay. If you have any question, you can send me in the WhatsApp. Okay. Have a nice weekend, and then again have a nice exam or have nice exams. Okay, see you. Goodbye.